Hello. Wanted to have a brief conversation around dataset preparation and kind of what it is and why do you care and why does it come up so much, right? Because it is a pervasive thing we see. And why the bigger question you may ask yourself is, well, first, what is it? And then more importantly, why do it? So why do we do it? And it's typically because the data that you're getting for pretty much whatever purpose you're going to get it for isn't going to be in the format that you need it to be. It's really unusual and exceedingly rare for the data to be aligned as you want it, cleansed as you want it, formatted and shaped the right way, and all that stuff. So what you will typically do is go through and cleanse the data by literally removing or adjusting the values of certain elements, obviously keeping track of what you do and documenting it as a way of saying, this is what I did with missing values. I used this form of imputation or whatever. Um, Also, you may deal with data that's not shaped the way you would like it to be shaped for your needs. And in particular, it may not be having the right number of columns, or you may need to turn things from being stored in a collection of columns to a collection of rows, so some sort of pivoting thing, and so on. It'll likely be incomplete, just as the nature of data. There's oftentimes values that are missing. And the reason is that we oftentimes capture data for one purpose and end up needing to use it for something else. If you captured it for the purpose that you were going to use it all the time, it would reason that you would likely have the data you need all of the time. But you're typically using it as for something else is the motivation. And there's also the occasional error exception that just occurs as well. So you oftentimes have noisy data. It may have data that is an outlier, so that you might want to remove certain data just because while it might have even been valid, you know it's going to throw off whatever it is you're doing with the data. People are involved. Anytime people are involved, there's typos, there's any number of human errors that they can make. You'll have inconsistencies in your data, such as duplication of data. And also, it may be not formatted or maybe formatted in a way that is difficult for you to read. So you may need to transform it from one particular type of binary format to another. And there may also not be enough data. So you may have to do something to either try to get by with what you have using some sort of a folding mechanism, or you may have to document that as a risk to your analytics, whatever it is that you've done. Keep in mind that you've always have this problem of garbage in, garbage out. So if you have bad data coming in to whatever it is you're doing, whatever type of analytics you're doing, be it some sort of AI-based stuff, ML, whatever it is, if the data that you're trying to do that upon is not good, you will not have good results. It's just the nature of how that works. The data quality will determine the quality of the result that are generated. And it may not even necessarily be something that is consistent as far as my data I know to be 80% correct, so I'll get 80% results, at least on my outcome. Maybe not. It may be that because of the nature of the noisiness of the data, you get a very poor outcome because it's unable to, it being the model, it may be unable to figure out what is going on inside of the data. You want to make sure of the quality of your data prior to actually using it. You're standing behind your results. As such, there is a bit of due diligence that's expected of anyone doing analytics, that they took a look at the data and it's essentially, as far as they know, correct and valid. So make sure that you do those steps. The things you do will depend upon the type of data you've got, if it's qualitative or quantitative results that you're doing, and so on. There's always going to be variations. If you're doing qualitative work, you're typically dealing with things that may be more around words, maybe about thematic research or something, than it is when you're dealing with quantitative, which is purely around numeric type computations. When you're doing quantitative data preparation, you're going to always do some form of imputing of missing values. Also, treating of outliers, you may remove them, you may aggregate them, you may just document them and get rid of them. There are certain situations you know that a person will not be 1,000 years old, but what about 120 or 130? even, right? Is something that is both likely, and would it potentially throw off your results if everybody else's maximum age is around, something far less? So if you've got a cluster of things and then you have one way out, that's what you would typically view as an outlier. Um, Data integration always is challenging because you're taking data from multiple source systems, possibly that are storing data and representing data in a different way. So you have to deal with some form of standardization, and we typically call that master data management. So ideally, you want to, whenever you're doing your data integrations, you would like it to where everything comes in and is on the same range, means the same thing. So if you have a gender bit that your values for that, or byte, whatever it is consistent across all of your systems. The same way with a date representation, your month, day, make sure that they're being represented the right way. And oftentimes you'll want to get things into the same format so that you can do easier prop operations against them. In the big data world, and especially in a lakehouse world, we get those into a lakehouse, and we have all of our data go through both a standardized set of operations, engineering activities to attest to the quality of the data. So in particular, going from bronze to silver, if nothing else, and there's an implied from the source system into the bronze system. Once we've done that stuff, we can then apply business rules, data quality rules in a consistent way because we're working within one unified governed environment. Sometimes you'll also need to deal with things like data discretization, converting your discrete values into from continuous to discrete, such as going from an infinite set to a set of binning or categorical values. You may switch from somebody's age to possibly age ranges. You may change categorical things into some sort of a byte array representation with some sort of one hot bit encoding or whatever mechanism you're using, some means of converting categorical to something that algorithms know how to deal with. You may also reduce the amount of data you're having because sometimes you can have too much. And especially if it's too much of so data, you want to have less higher quality data than more lower quality data. So how do you do these sort of things? Well, it's a combination of skills that are involved. You will also have a certain amount of analytical capabilities. So you as a data engineer would go in and take a look at the data and do some validation and do a certain amount of validation that it is valid and true and proper data, that there's been no falsification going on, for one thing. As a data analyst, you are responsible for knowing the history and the lineage of your data, where it came from and what was done to it. It's not quite to the same level as like in the legal system of some sort of ownership or governance of evidence and so on, but it is something that is quite sensitive, that you make sure you know what's from where. Oftentimes we don't have to worry about this stuff, but if you're dealing with some sort of regulatory testing, you're going to want to know where that stuff is coming from, because there may be an incentive for people to be deceptive. Data tabulations where you're actually doing the real counting programmatically, oftentimes to do the work. Some common data strategies. Imputation is a key one, where you're putting some way of handling missing values. You may be taking something simple as ignore it. You may put in a consistent value, always 0 or something, or maybe the average, or you might just remove the records. You're going to do something to make sure that they're not present. You'll get rid of redundant data, and this is data that is dependent upon other or derived from other data. You don't want data that came in as the source data. It's been changed in some fashion, and then it's used in conjunction with data that is derived from it. So make sure that what you're using is of the same lineage, and you can point to it so that you're not using the offspring of a data set as part of, in combination with that data set. You do want to normalize your data. And this is oftentimes to make sure that everything is on the same scale. you'll often want to get rid of some of your outliers as well, and removing them so that you have a reasonable distribution of your data. And we oftentimes have reasons for doing this stuff. So what's the point? And it's all about your organizational goals, right? So what is the point of an organization doing data analytics? This is a question that oftentimes doesn't come up whenever you're dealing with some advanced data science and AI and ML classes. There needs to be a value being derived from the energies that you're doing, the activities that you're taking on. Otherwise, you're not making the company any money or saving it money. And that's what this should be. We don't do research just because it's cool to know the answer. We do so that we can materialize or capitalize upon that outcome in such a way that it is impactful to our organization and justifies our compensation for us doing the work that we did. There's several ways that we do that. You come up with short and long-term objectives and goals. You want to make sure that you're aligning the things that we're doing, the strategies, to the long-term strategy. You also want to have a short-term strategy to help you in the immediate needs. But sometimes you'll need to do things like come up with a conceptual framework of how things all fit together. Make sure you provide direction within the organization to meet the goals of the organization. You want to make sure that you're prioritizing and putting resources on the important stuff, because you don't want to be spending scarce resource, be it people or money, in a way that is not mindful and to the benefit of the organization. You want to make sure that employees are motivated and that there's an interest in them, feeling that they're empowered and helping with the decision-making process, and make sure that there's a clear definition of what success looks like and that all stakeholders are aligned. Those things are all important before you start doing any kind of data analytics, although they do go hand in hand. You want to make sure that you're having a business impact and that business impact is measurable. You want to make sure that you do so by aligning it with the organizational objectives, making sure it's been defined, that you know what that impact should look like, and be able to measure it and determine, yes, I did meet my goals, and here's how, and demonstrate why you did a good job with what it was you were asked to do. And so you need to go and figure out, how do you answer these business questions with the data? In order to do so, you need to come up with, first, who are the subject matter experts that know about that data, understand what data is available, what are the limitations of the data that is available, both the data technology, the resources, and potentially money and computational costs and time to do the analytics. Make sure there's a clear understanding of all terms, metrics, and benchmarks. I don't know how many times I've seen this multiple people in a room thinking they're all talking about the same metric, and they are not. They're calculating them quite differently and not understanding why there's a disconnect, and understanding that it may depend upon your perspective, right? Understand the projected cost and making sure that you can justify a return on investment for that cost. And the benefits for having done the project. So what is the outcome, and is it reducing cost, reducing risk, improving profits, generating leads? Make sure whatever that thing is, that it is well known and documented, and that everybody is on the same page, and making sure that it's clear to know how you're going to measure before you start doing anything. Make sure you know how you're going to measure the results. You want to make sure that you have a clarity to the objective. And so this is making sure you have a poor understanding of your business problem will result in poor outcomes. You need to understand the problem clear and concisely so that you know for sure that you're able to answer it or not. You want to make sure that you know what the objective is, and make sure that you've clarified that with the relevant stakeholder. Once you've done all that stuff, then you need to figure out how you're going to actually get the thing done, how you're going to build it, deploy it, where is it going to run, how long is it going to run, and so on, who's going to keep it running. All of that stuff has to be figured out. And then you need to make sure that you're building an accurate model. And even if you do have an accurate model, you need to make sure that it's aligned with the business objectives, or it won't do you very much good. So the goals, again, continuing the goals of an analytical organization, we want to make sure we talk about the destination of where we're going to end up, and then talk about how you're going to get there and how you're supporting decision making through these analytics capabilities. And making sure that data analytics is visible throughout the organization, making sure that you have standard processes and procedures for acquiring tools, techniques, and so on, making sure everybody's doing things in a similar way, ideally. You want to make sure that you're doing it the way that most people do it today, not how they did it in the past, because oftentimes the approaches that we use differ over time. And what was cutting edge 5 years ago may be it may be a counter example today, an anti-pattern that you're to avoid whenever you're doing data engineering or data analytics in general. So you want to make sure you're keeping up to date with changing procedures, make sure that things that you're doing are cost effective. There may be a lower cost way of delivering, and making sure you're keeping track of the analytics capabilities. Whenever we gather and transform data, you need to find where it's coming from. And so there's an overall process you go through to do this, and you make sure that it's documented and that you follow it with a series of tests or tasks that are outcoming. Make sure that you have all of the things that you expect to be done within your organization documented, so that people are doing things the same way and that there's no misalignment in how they're doing it across organizations. When we talk about data, it has a life cycle. It starts with a plan, then you collect it, you test it, assure it, make sure that it is valid, describe it, preserve it, discover some more of it, likely, integrate it, analyze, and then based upon that analysis, repeat the cycle. We're going to go through these really quickly. The plan, come up with what it is you're going to do and making sure the stakeholders are aligned. Start with, how do you know what data you're going to need, and how do you make sure that you're getting the minimum amount that is necessary, but the stuff that is necessary to answer the questions. Make sure that you know things like the freshness of your data, the validity, the accuracy, all of that stuff, to make sure that you can be certain that it is of the quality that you think it is. Make sure that you're able to know about the data and be able to do some descriptive analytics and do some visualization and some very simple graphical representations of some sort. Oftentimes, you may be able to see patterns in your data you don't see otherwise. Make sure you got a way of preserving your data. A lot of times research, especially clinical research, needs to be filed away for a certain amount of time. So make sure that you have a plan for doing so. For example, whenever I finished my doctorate, I had to preserve my recordings and files and so on for a period of 5 years. So, and documented the fact that that's what would be done. And then that it would be disposed of securely. Go out and discover. Data discovery is an important part of the process. That's where you learn the nuances of the data. Then you'll start tying it all together through integration, figuring out how to hook pieces together, do some analysis. And this is where you also are looking back to see how well you did. And so did you meet the goals of the organization's objectives or not? If you have any questions about the material, do feel free to reach out, send me a message on whatever platform. As always, if you have questions, let me know. If you like what I'm doing, let me know that as well. Talk with you later, and I'll try to continue the journey towards artificial intelligence.